Welcome. So this question says a 3 kilogram block has an acceleration of 1.5 meters per second squared, pointing down the slope. What is the coefficient of kinetic friction for the block and the incline? So let's draw this again. So there's my incline. It's 20 degrees to the horizontal. Let's put a nice small block on it. I have a series of forces. I have a force downwards. It's a 3 kilogram block, so that will be 30 newtons. I must have a normal force, that's an Fn. And there's going to be a frictional force, Ff, because it wants a coefficient of friction. No other forces are indicated. There's no reason to think that there's an applied force that's been pushed or anything like that. If there was, it would say so. There is one more piece of information which is important, which is the acceleration. There is an acceleration. It's not a force, so I want to kind of indicate it in a different color. And I want to put it somewhere it's not going to particularly mess up my diagram. I can write it anywhere as long as it's in the right direction. And this is 1.5 meters per second squared. It's down the slope, so that's 1.5 meters per second squared down the slope. What that tells me, because it's an acceleration, that tells me that I'm in a non-equilibrium position. What do I want to find? I want to try and find my coefficient of kinetic friction, so Ff is equal to mu k times Fn, so mu k is equal to Ff over Fn. I do a lot of these, and one of the reasons I do a lot of these is because they're one step beyond trying to find Ff or trying to find Fn. So by showing you these, I'm on the way to finding mu k. I'm also demonstrating how you would find Ff if you were only asked for Ff, or you would find Fn if you only find Fn. The trick with a question where you have an acceleration is to determine the direction of the acceleration and then resolve your forces in that direction using the sum of the forces equals ma. So I would say find, in this case, I'm going to be perpendicular to Fn, so I'm not going to find Fn. I'm going to say find Ff using the sum of the forces along the slope equals, not 0 because it's not in equilibrium, it equals ma. And so I look at my diagram and I recognize that I have a component of the 30 newtons along the slope. And as I say, I hope you get into the stage where you can write down 30 sine 20 without much effort. And so I say, let's make this end positive and this end negative. And I say plus Ff, because that's in the positive direction, added to minus 30 sine 20 is equal to, not 0 because it's not in equilibrium, is equal to, then I wrote down 0. Not 0 because it's not in equilibrium, is equal to the mass, and the mass in this case is 3 times the acceleration. And we've been told the acceleration. The acceleration is 1.5 meters per second squared. But here's the little thing you might miss. That 1.5 meters per second squared is pointing down the slope. And so down the slope is negative. And so that's a minus 1.5 meters per second squared. And again, a good diagram will help you catch that. Whereas a poorer diagram, you might miss it. So Ff is equal to 30 sine 20 plus minus 4.5. So FF is equal to, I'm going to work this out, go to my calculator, 30 sine 20 equals, it's going to be 10.26 minus 4.5 is equal to 5.76. So this would be 5.76 newtons, and it's a positive, it's pointing in the positive direction. Okay, so next I need to find my Fn, and my Fn is going to be found by resolving my forces. Let's divide this up into this bit. So now Fn, find Fn using, and here having gone horizontally, having gone down the slope and said the sum of the forces equals ma, and I know the value of the acceleration. The obvious thing to do now is to go perpendicular to the slope. It's the only direction where that acceleration has no component. So I know that perpendicular to the slope, I am in equilibrium. So find Fn using the sum of the forces, and the way I do perpendicular is I do a little sign like that, and then I say slope. Now I could use a colored pen and do, along the green line, but as long as I'm telling myself what I'm doing is equal to 0. Perpendicular to slope, well, I have this component of my 30 newtons, and this will be 30 cosine 20. So I say, in that case, let's have a positive end and a negative end. So I go plus Fn added to minus 30 cosine 20 is equal to 0. So Fn is equal to, it's going to be 30 cosine of 20 is equal to 28.19. So there's my next bit. And then I want to come back to this. Mu k is equal to ff over fn, which equals 28.19 over 5.76 equals. So we have 28.19 divided by 5.76 equals, that's going to be 4.89, which is not there. So what have I done wrong? 28.19 divided by 5.76. Oh, I am wrong. So let's just go back and check. So 30 cosine 20 equals 28.19. And have I got them upside down? Yeah. Oh well. It's been a long day. So I have FF is going to be 5.76 over 28.19, and that equals, so 5.76 divided by 28.19, and that equals 0.20. Yeah, 0.20. Newtons over newtons means no units, it's dimensionless. I do try and make it as live as possible, so occasionally I suppose I'm going to just make a mistake like that. So there's my answer. So just to recap briefly, so I did a decent drawing, big arrows, small little block. I see people with big blocks and small arrows, and it hides the geometry. So try to draw big arrows with little blocks. Try to make the angles reasonably right. And then what I do is I try and solve it in one step. Okay, rearrange, I need FF, I need FN. I use my standard techniques. The only thing I'd say here is that because I had an acceleration down the slope, I am going to resolve down that slope because it's the only direction that I know my acceleration. And then I go 90 degrees to that acceleration, and that is the only direction in which I know that the acceleration equals 0. I do my sums and I end up with an answer. So there we have it.